Welcome back. We are moving on to Unit 3 now, and Unit 3 is about quadratic equations, and we will be learning several techniques. The first one we're going to learn is about factoring, okay? So we're going to solve quadratic equations by factoring. However, there were some things that we haven't learned, okay, that we did not learn in Math 10. In the previous unit, I think I showed you that we learned how to factor simple trinomials. However, complex trinomials, we have not learned about that yet. So that's what I'm going to show you today, okay? And other different kind of factoring techniques. So here, let's just review on what we did in the past. Here is a polynomial expression, and we can factor this. This is just a binomial, and all we can do here is we can factor out the common factors. Okay, so in this case, the common factors so remember, when we look for common factors, we look for numbers with numbers. Okay, so 3 and 15, the common factor is a 3. The x with the x, so that's x squared, that's x cubed, so the common factor there is x squared. Okay, that's what they both have in common. And if we look for the y, one single y is the common factor because you have y in each one of those two terms. Now when you factor, what you need to do is to divide, right? So 3 divided by 3 is 1, x squared divided by x squared is 1, y to the power of 6 divided by y is y to the power of 5, minus 15 divided by 3 is 5, x cubed divided by x squared is x, and then y divided by y, well then that's just y, okay? Oh, sorry, there's just 1, so then we don't need to write it, and that's it. This is the factor form, okay? This is the factor form. Factored form. Okay, so this is how you do it if there is only common factor only. Okay, now this is the trinomial with leading coefficient 1. So this is what you did in Math 10, and we saw several of these trinomials in the previous unit. So what we do is we're looking for two numbers multiplied to negative 21, and these two same numbers should add up to the middle term, which is negative 4. In this case, it's going to be negative 7 times 3. That gives us negative 21. And we notice that negative 7 plus 3 is negative 4. Okay, so negative 7 and 3 are the numbers that we're going to use. And when you factor simple trinomials, it's always going to start with x, and x there. It's negative 7, that's the number we got, and then the positive 3, that's the number we got, and that's it. If you're not sure, you can always check by expanding. Okay, you can always check by expanding. So I'm just going to show you how to check, I suppose, with this question, and then you can do the rest if you wanted to. Okay, x times x, that's x squared, x times positive 3, that's 3x, negative 7 times x is negative 7x, negative 7 times 3 is negative 21. Now you can combine like terms right here. 3 minus 7 is negative 4. So we have negative 4x, and we still have the negative 21, and you can see this is the same as that. Okay, so we just show that we did it right. Okay, that is indeed how you factor. Okay, so this is the answer. Okay, now the second one, you may have seen this in Math 10, you may not, I don't know, depends on the teacher if they decide to show you this or not. So this looks a little bit more complicated than the first example that I just showed you. However, they're actually almost exactly the same. Okay, I'm going to show you a little trick. So what I'm going to do is, you can see this is something squared minus 4 times something minus 21. If you look at this question and the previous one right here, they're almost the same thing, except instead of x squared, we have x minus 1 squared. Instead of minus 4x, we have minus 4 times x minus 1. The minus 21, the constant there is the same. So what I'm going to do is this. I'm going to say let's say a equals to x minus 1. Okay, if I do that, I'm simply replacing x minus 1 with a. So I see x minus 1 here. Instead of that, I'm going to write this as a squared. And instead of 4 times x minus 1, I'm going to write this as minus 4a. Again, I'm letting x minus 1 equal to a. And minus 21 is still minus 21. Now you can see this then is exactly the same as that, right? It's a different variable. So that means if we factor this, we should get exactly the same answer, which is going to be a minus 7 times a plus 3. Now, once you finish this, you're almost done. The question was never about a, right? It was x and x. So what we're going to do now is we're going to replace this a, these two a's, with x minus 1, because I mean ultimately a is, or our assumption, our assumption was a is equal to x minus 1. So now we're going to replace a with x minus 1. We still have the minus 7 there. We're going to replace a with x minus 1. We still have the plus 3 there. Okay, so a turned into x minus 1, a turned into x minus 1, the minus 7 and the plus 3 remains. Now we just need to simplify the brackets here. X minus 1 minus 7 is x minus 8. X minus 1 plus 3 is x plus 2. And there is your final answer. Okay, so that's the little trick that we can use. All right, that's the simple trinomial with leading coefficient 1. The second type is going to be a trinomial with common factors. So then you can see you have 3, you have 6, you have 24 here. Those are all multiples of 3. So what we can do first is factor out the 3. Okay, so if you factor the 3, you should get x squared minus 2x minus 8. And once you do that, then we have a simple trinomial right here that we can easily factor. Again, we're looking for two numbers multiplied to negative 8. And the same two numbers should add up to negative 2, right? Again, the numbers multiply to the constant and add up to the middle term. And it would be negative 4 times 2 in this case. Negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2. So again, when you factor simple trinomials, it always starts with the x's. And the numbers we got were negative 4 and positive 2. And that is our final answer. Okay. This one, I'm going to ask you to try it. Okay, so good luck. Okay, so that's what you should have. Again, there's the common factor of 2, so factor that out. We end up with 2 brackets x minus y squared minus 4 times x minus y minus 12. And now I'm using the same trick that I showed you earlier. I'm gonna let a equals to x minus y. So that's what I did. And now that's a simple trinomial. I can factor that easily. After that, I can replace x minus y, or replace a with x minus y there. And then there's your answer. Okay, you cannot simplify this even more. So that is the end. Okay, all right. So these really are the ones that we learned in Math 10. Now I'm going to show you what if we have a trinomial where the leading coefficient is not 1. Okay, so this is what we call the complex trinomial. Because, well, it's a little bit more complex, but it's not that bad. Okay, I'm going to show you 3 different methods. Okay, so you pick the one you like. It doesn't really matter which one you use. Okay, I'll show you the first one, which is the most systematic. It always works. There's no exceptions. But it takes the longest time. Okay, so I'll show you this. So what you're gonna do with the complex trinomial, again, the first thing you always do though is look for common factors. Now that's 3, that's 5, that's negative 12. There's no common factor there. So then you can see this is a trinomial and the leading coefficient is not 1. In that case, this is what you can do. Okay, this is the decomposition method. So what you're going to do is you're going to multiply the first digit, the leading coefficient, with the constant term. So 3 times negative 12 is negative 36. So it's actually similar to how we did it earlier with this kind of method. We had negative 8 here, and that came from the constant term. So we are going to do something similar, except now it's not going to be negative 12. It's going to be 3 times negative 12, which is negative 36. And we are looking for the same two numbers, and this part is the same, add to the middle term. Okay, so you need to think about which two numbers multiply to negative 36. And again, this negative 36 came from 3 times negative 12. And those two numbers add up to 5. And these two numbers will be 9 times negative 4, 9 times negative 4. So what I'm going to do right now is I'm going to decompose the middle term. Okay, I'm going to split 5x into 2 terms. So then this is equal to 3x squared. Instead of plus 5x, I'm going to rewrite this as plus 9x minus 4x. Okay, notice 9 minus 4 is 5. You might ask, where did I get the 9 and the negative 4 from? Well, that's exactly what these two numbers are used for right here. Okay, so 5 came from the two numbers that we got right here, 9 minus 4. So there's the 9x minus 4x. And then we still have the minus 12. Notice how these two are exactly the same, right? There's no difference. I just made it bigger, okay? Okay, so now what I'm going to do next is I am going to factor. You can now what you're going to do is you're going to split, there are four terms here. You're going to split them into two groups, okay? First two terms and last two terms. You can factor the first two terms, okay? Look for the common factor. 3x is the common factor. If you factor 3x out, you should get x plus 3. Okay, divide everything by 3x, that's what you get. And you can factor the last two terms, okay, separately. That's negative 4x, that's negative 12. What I can factor out here is negative 4. And if I divide the negative 4x minus 12 with negative 4, I should also end up with x plus 3. This is the key right here. These two brackets must be the same. If they are not the same, that means you made a mistake, okay? That means you made a mistake. Now, the last step is, since these two brackets are the same, we can actually factor that out, okay? Again, both terms, we have two terms, and both terms have the same x plus 3 brackets, okay? So we can actually factor that out. I can factor x plus 3 out. And if I take x plus 3 out of the first term, I end up with 3x. If I take out x plus 3 from the second term, I end up with negative 4. And that's my answer. Okay, that's it. The end. That is the first method. This method is called decomposition. Okay, decomposition. Okay, that's the first method. I will show you the second method. I'm gonna need more room here, so I might write to the next page. Okay, I'm gonna use a different color so you can see the difference. Okay. Okay, second method. This is called, I believe, called AC method. Whatever, doesn't really matter what it's called. Okay, so somewhat similar. Okay, but this method is not that bad. But this method you really need to watch out for. You need to make sure that the leading coefficient is not negative, it's positive, and that you must factor out a common factor first. Okay, if you don't factor out a common factor, then you can't do it. Okay, you should factor out a common factor anyways, regardless. Okay, so what I'm going to do with this AC method, okay, it's called AC because it has something to do with A and C right here. Okay, so what I'm going to do is I'm going to write down the question first. Okay, let me just rewrite the question. So the first step that you do is, just like the decomposition, you are going to multiply the leading coefficient with the constant term. And what you're going to do is you're actually going to get rid of the leading coefficient. And now once you multiply 3 with negative 12, you actually end up with negative 36. Okay, so I'm changing this to a simple trinomial for now. Okay, for the meantime. Okay, obviously we have to change it back because they are not really the same thing. Okay, they are not the same. Okay, now, but if you treat this just like a simple trinomial, then in that case we can actually factor this quite easily. Okay, you need to think about which two numbers multiply to negative 36 and add to positive 5. We actually did that already. It was 9 and negative 4. So what I'm going to do is I'm going to write this as x plus 9 and x minus 4. Okay, so that's what I did. Okay, now we kind of just randomly multiply the 3 with negative 12. Okay, so now what I'm going to do is I'm going to go backwards. So then we kind of get that 3 back. So that was multiplication by 3. So now what I'm going to do is I'm going to actually divide these two numbers by 3. Okay, maybe I should write that in different color. Okay, so what I'm going to do now is I'm going to divide this by 3, divide that by 3. Okay, so then you end up, then you can simplify this. You actually get x plus 3. Now this 4 over 3 is not, let me repeat, it's not a nice number. I mean, it's not a bad number, but then it's not a whole, it's not an integer, right? Like positive 3 right here. So what I'm going to do is I'm going to move this 3 to the front. So this becomes 3x minus 4. So essentially I multiply everything by 3 right here in this set of brackets. Okay, so you do not want to keep a fraction there. So I multiply this x by 3 and I multiply the 4/3 by 3. I get negative 4. And you can see this is the same answer as that. And I'm done. Okay, so this is the AC method. Okay, if you don't understand, again, you can go back and rewatch it, okay? Now I'm going to show you a third method, okay? The third method. This method is called guess and check. There's no other way to put it, okay? It's just called guess and check. Okay. Maybe I'll write the name down actually. Okay, so this is called decomposition. Decomposition. And this is called AC method. Or at least I call it AC method. And finally, the one I'm going to show is called guess and check. Okay, so it's trinomial. So let me just write down the numbers here. So the question is 3x squared plus 5x minus 12. I know this is trinomial, so if I factor it, it's going to be 2 set of brackets. Okay, now what I need to think about is how do I get this 3? Well, this term, the first term, really came from the first number, or this term times that term. How do I get a negative 12 here? Well, that came from this times that, right? It's always x plus something or minus something times, some x plus or some minus number, right? So how do I get this 3x? Really, the only way I can get 3x squared is by multiplying x with 3x. Guaranteed. Now, obviously, you could also say that, you can write 3x first. It doesn't really matter, okay? The order does not matter, okay? Now, the next question you need to think about is, well, how do I get negative 12? So there are several choices, right? 1 times negative 12, or negative 1 times 12, 2 times negative 6, negative 2 times 6, 4 times negative 3, negative 4 times 3. I believe those 6 are the only choices. So now how do I know which one to use? Okay, well, we don't. You kind of need to guess and check. Okay, so this method is really good if you have good number sense, because then you can kind of do quick math in your head. But, I mean, ultimately, you need to pick a combination. And what you need to do is you need to think about the middle term, really. Because we know that if we expand it, it has to add to 5. Okay, so I'm just going to do something random. Okay, I'm going to say 6 and negative 2. So I'm going to say x plus 6 and then 3x minus 2. Because I know that 6 times negative 2 is negative 12. So that does work. However, do they actually add to 5x if we expand it? Well, if we were to expand this, we go x times 3x. Sure, that's 3x squared, that's good. And we have x times negative 2, that's negative 2x. 6 times 3x, that's 18x. Okay, so now 18 minus 2 is 16, not quite 5. However, I mean, it does work that 6 times negative 2 is negative 12, but the middle term does not work. So we know that 6 and negative 2, this combination does not work. So you gotta try something else. Let me tell you what it's gonna be here. It's going to be, let me see here, 5. So I am going to need to have 4 and 3. Okay, so I need negative 4 here and positive 3 here. Yes, this is gonna work. You can see. Okay, again, 3x times 3x is 3x squared. 3 times negative 4 is negative 12. Now the middle term, x times negative 4x. Sorry, x times negative 4 is negative 4x. 3 times 3x is positive 9x. 9 minus 4, definitely 5. And there you go. That's the answer. Okay, you see, it's the same answer as what we got right here. Guess and check. Okay, so again, like I said, there are actually more than just these 3 methods out there. There's tons of methods on how to factor, okay? This is the most basic method, decomposition. That's the one I usually teach my grade 10s. Math 11, I probably use AC method. Right now, I don't use any of these 2. I just guess and check. Okay, so I think once you do enough, guess and check is the best. Sometimes though you do get stuck because it's not that easy to guess and check. Okay, so your choice. Okay, you pick which method you prefer. It doesn't really matter to me. There are 3 more questions here. I'm just gonna show you different methods show you one method for each question. Okay, so for this one, I'm going to show you decomposition. So decomposition, again, this is decomposition. Okay, so what you do, again, first, always look for greatest common factor. There's none here. So what you do with decomposition is you go 4 times 6, which is 24. So then you're looking for two numbers multiplied to 24, and the same two numbers add up to negative 11. And these two numbers are negative 8 and negative 3. Okay. Okay, so now we can decompose the middle term of negative 11x into negative 8x minus 3x plus 6. You can factor the first two terms and last two terms separately. For the first two terms, you can factor out 4x. You get x minus 2. For the second two terms, you can factor out negative 3. You get x minus 2. Okay, again, the key for decomposition is that these two brackets must be the same. And really, this is the only method that you can actually check your work, kind of. Because that is really, for me, the checkpoint. Okay, if they are not the same, that means you made a mistake. Okay, if they are the same, like what we have here, then you can factor x minus 2 here. And then you end up with, well, if you take x minus 2 out of first term here, you end up with 4x. If you take out the x minus 2 out of the second term, you end up with minus 3 there, or negative 3. So that's the answer. Okay. If you want, you can try this question with AC method or just guess and check. Okay. Okay, moving on. We actually have a few questions left. Okay, so this is a different type of question. It says trinomial with leading coefficient, not 1, and with a common factor. Okay, so now this right here, really it's not really a common factor, but we have a fraction here, which is terrible. Okay, so we don't want a fraction there. So what we can do is we can actually factor something out. We factored 1 over 2 out. Okay, so when we factor, remember we are dividing. So 3 divided by half, it's like you're doubling 3. So that's 6x squared. And the reason why we factor 1/2 out is because when we factor half out of 29 over 2, we simply get 29x. And then if you factor 1/2 out of 14, you get 28. Okay, now this is the one I would probably try guess and check, because regardless of whether you use decomposition or AC method, you have to multiply 6 with 28. And, you know, that kind of is big. Okay, so in this case, I'm going to try guess and check. Okay, so I still have 1/2. Now I'm going to guess and check. Now 6, two combinations, either 1 times 6 or 2 times 3. I have a gut feeling. I think it's 2 times 3. Okay, I don't know actually. Okay, I don't know. Again, that's just guess and check. Okay, you try that first, see how it goes. If it doesn't look right, then you try 1 and 6. Now 28, 3 combinations I think, or 6. 1 times 28, or the negative 1 times negative 28, 2 times 14, or 4 times 7. Now I know in this case both will have to be negative because they have to add up to negative 29. So they cannot be both positive. Okay, so they have to be both negative. I'm gonna say it's 4 and 7. And let me see here, is that right? If I put a 7 here, I put a 4 here, that's 14. 2 times 7 is 14. 4 times 3 is 12. 14 plus 12 is only 26. So this is not right. What if I flip the numbers, put a 7 here and 4 there? 2 times 4 is 8. 7 times 3 is 21. 21 plus 8 is 29. I'm done. That's it. That's it. This is the answer. Okay, that's it. Okay. I don't know if you're in shock or not, but we're done. Okay. Anyways, maybe you're not in shock. I am in shock. Okay. Next example here. This is a typical one where we have a common factor. We can factor out the 2. We get 3x squared minus 17x minus 6. I'm going to use AC method in this case because I already used the other two. So AC method, what you do is you multiply the leading coefficient with the constant term at the end. So you have to carry the 2 with you, okay? Then you end up with negative 18, right? 3 times negative 6 is negative 18. So you multiply these two together. And now this is like a simple trinomial. So you would just factor like you would for simple trinomial. You're thinking what two numbers multiply to negative 18 and add to negative 17. The numbers will be negative 18 times positive 1. And again, because we multiply 3 here first, so now we need to kind of get that 3 back by dividing both these two terms, or these two constants, by 3. This is a nice number, so we can actually divide that, you get a 6. This 1/3 is not an integer, so what I'm going to do, again, we can bring this 3 to the front, we get 3x plus 1, and this would be the answer. Okay, so that's the AC method. Okay, again, I show you 3 different methods. You pick your favorite one. It does not matter. I don't care which one you use. Okay, and on the test, I'm not going to ask you to use this method only, okay, or that method only. You pick your method. I don't care. All right, the next one here, this is what we call the difference of squares. I believe you've seen it in Math 10 as well, but if you don't remember, I'll show you. It's called difference of squares because both x squared and 4 are perfect squares. I'm going to rewrite this. I'm going to rewrite this as x squared minus 2 squared, right? They're different. Again, difference because it's subtraction of 2 perfect squares. So now to factor this is actually quite easy. Again, when you factor, you get 2, well, not always, but difference of squares, you do get 2 set of brackets. You get x and x in the front. These two x came from the first bracket, x. You get 2 and 2, and these two 2's came from the second set of brackets. You get a plus sign, and you get a minus sign. You're done. That's it. The end. Okay? Why don't you try it for the second one? Okay? So the key here is first, write this as difference of squares. We can write 16x squared as a perfect square. That is going to be 4x, right? 4x squared is 16x squared. 9y squared, if you square root that, you get 3y. 3y squared is 9y squared. So then, once we have this set up, it's easy. 2 set of brackets, 4x, 4x, 3y, 3y, 1 plus, 1 minus. Done. Okay, you might ask, Mr. H, can I write minus sign first and then plus sign? Of course, it's fine. Not a big deal. Same thing. Okay, the order, when we multiply, the order does not matter. Okay, that's difference of squares. It's actually quite easy. Okay, now we have 3 kind of fun ones to do here. This one you already know what to do, right? What you need to do here is you just make your assumption here, right? Let statement, let x minus 3 equals a. And then you factor from here. Okay, so then this becomes 6a squared minus 19a minus 7. Okay, so again, I'm going to stop here and I'll let you try it. You pick your method, okay? Okay, I am going to use my favorite method, which is guess and check. I think, again, 6. I'm just going to go, I always go with 3 and 2, okay? That's just my gut feeling. I don't know. 7, so it's going to be 7 and 1 only. 7 and 1. And has to be 1 positive, 1 negative because it's negative 7. Okay, I got it. It's 3a, 2a, minus 7 here, plus 2 here. Oh, no, this is not right. Oh, this is, no, oh, it's plus 1. What am I doing here? It's plus 1. Right, because 3 times 2a is 6a squared. That's negative 21 plus 2 is negative 19. That's perfect. And now what I'm going to do is substitute x minus 3 back. So you have 3 times, okay, be careful, x minus 3 plus 1. 2 times x minus 3 minus 7. Okay, now expand. You should get 3x minus 9 plus 1. And you have 2x minus 6 minus 7. Combine like terms inside the brackets. You should get 3x minus 8 and 2x minus 13. And that's your final answer. Let me just get a little bit more room here. There you go. Okay. Next one. This one is a difference of squares. I don't know if you can tell. You might think, okay, well, but that's 32 and that's 18. They are not perfect squares. Well, again, that's why you factor out the common factor first. You can factor out the 2. You get 16. 2x plus 3 squared minus 9. 3y minus 1 squared. You can rewrite this as a perfect square. This is going to be 2. And then 4. And then 2x plus 3 squared, right? watch this. 4 squared, 16, right? 2x plus 3 squared. Well, 2x plus 3 squared. That's right there, okay? Minus, this is going to be 3 bracket 3y minus 1 close bracket squared, and then the square bracket right there. Again, square root of 9, 3, square root of 3y minus 1 squared, 3y minus 1. And then there's the square. So what we can do right now is we can actually simplify the brackets, the inner brackets first. Okay, so that's 4 times 2x, that's 8x. 4 times 3 is 12. Minus 3 times 3y is 9y. 3 times negative 1 is negative 3 squared. Okay, now this again is then, you can see, difference of squares. So now we know how to factor this. It's going to be 8x plus 12 plus 9y minus 3 times 8x plus 12 minus, okay, be careful because it's minus, so it's going to be minus 9y, and it's going to be minus negative 3, so it's actually a plus 3 here. Okay, so that's, watch out for the sign, okay? Easily making a mistake right there, okay? Happens all the time. Okay, so again, it's minus negative 3. That's why it's plus 3 here. Okay, so now we collect like terms for each set of brackets. That's 8x plus 9y. 12 minus 3 is plus 9. Second set of brackets, 8x minus 9y. 12 plus 3 is 15. And there's your final answer right here. Okay, so a little bit longer, okay, but it's doable. All right. Last example that we're going to do right here. So this time we have decimals. It's the same thing though, okay? Same thing. Basically, this is a simple trinomial. So you're looking for two numbers multiplied to negative 1.2. And the same two numbers add up to positive 1.4. Is there such a thing? Negative 0. Oh, yeah, that's right, we do. It's 2 times negative 6. Negative 0.6. That's negative 1.2. And 2 plus negative 0.6, that's positive 1.4. That's right. So then your answer is x plus 2, x minus 0.6. That is your final answer. Okay, so decimals, it works the same way as how we did it in with integers. It's just decimals, that's all. Okay, or what you could do is you can factor 0.1 out. Okay, or this might be easier, I don't know, if you factor 0.1 out. And the reason why we factor 0.1 out is because there's one decimal point and one decimal point. If you do that, you actually get 10x squared plus 14x minus 6. Okay. Oh, sorry, I don't know why it's minus 6. Minus 12. And you can then factor the 2 out. So if you factor the 2 out, times 0.1, you get 0.2. And that's 5x squared plus 7x minus 6. I don't think this is faster, okay? You're doing more steps. And now you see this, okay, you know what? Never mind. Bad idea. Bad idea. You then end up with complex trinomial, okay? So you could, if you wanted to, I would say just do it like that, okay? You know what? I'm going to do a guess and check method because it shouldn't take that long. It should be 5x and x. 6 and 2. No, 6 and 3, sorry. So plus 2 minus 3. Yeah, that's it. So if you want, you can write it like that too. Okay, definitely not better. Okay, so that's it. That's the factoring lesson. Do some questions. Let me know if you need some help. 3 different methods. Just pick one. Okay, good luck.